All right, so what we're going to do today is we're going to begin our look at the sine rules. Because remember, all algebra is built up of terms, and all terms have four parts, and the first part of every term is its what? Sine, right? And so by sines, what I mean are those pluses and minuses. In arithmetic, we think of those pluses and minuses as being addition or subtraction. But in algebra, the pluses and minuses become the signs of the term that you're dealing with. And if you change that idea, then what it does is it changes the way they work. And this is probably one of the most problematic sections or ideas for students to grasp, but it has nothing to do with it being difficult. It has everything to do with being detail-oriented and being careful. Those are the things that give you problems. It's not that the rules are hard. You're going to see I'm going to write 2 sentences. We're going to be out of here in 20 minutes today. But you've got to know those 2 sentences. And you've got to know when to use those 2 sentences. Okay? So the whole problem with sines, again, is not that the rules are difficult. The whole problem with sines is that you're not careful or attentive enough to follow the rule when you need to. Okay? So that's the big deal. Mathematics is not one of those topics where I kind of know what I'm doing, so that'll get me by, right? You've got to know exactly what to do at all times. So you have to change your habits to make sure that you're really paying attention. So the sine rules. What we're going to do is we're going to look at the sine rules for all 4 operations, but we're going to break them in half and do some today and some tomorrow. What we're going to do today is we're going to look at the sine rules. Or Tuesday. Yeah, there you go. You're not coming tomorrow?
Like next week.
Okay, all right. You're going to come extra credit. Multiplication and division. The sine rules for multiplication and division are exactly the same, which makes it nice because it's one set of rules for both multiplication and division. Now, the operations of multiply and division don't mean the same thing, right? You multiply or divide, that never change. That doesn't change. But the sine rules are the same for each one of them. And what I mean by the sine rules is you need to determine, is my answer going to be a plus, which stands for a positive, or a minus, which now stands for a negative? Because again, we can't think of those signs as being add or subtract anymore. We have to think of them as meaning either positive or negative. Okay? Positive if it's a plus, negative if it's a minus. All right, so what we're going to do is I'm going to give you 2 sentences that will explain every bit of this. The 2 rules are just 2 sentences. The first rule for multiplication and division. Now again, remember, it's like fractions. It's not good enough to know it's addition. You have to know addition with fraction, right? So you have to be careful about what rules that you're using and what operations you have. The first rule says that if the signs are the same, if the signs are the same. Now what does it mean if I mean by the signs are the same? Both negative or both positive, right? 2 positives, 2 negatives. That means the numbers you're working with have the same sign. They can be either positive or negative. It doesn't matter. If the signs are the same, then your answer is always positive. It doesn't matter what signs you start with in the beginning. When you're doing multiplication and division, if those signs are the same, the answer you get will always be a what? Positive. So, a positive times a positive is still a positive. A negative times a negative is a positive.
So it's going to be positive.
Okay? Always, yeah. Okay? So if the signs are the same, the answer is always positive. That's the first rule. The second one says, that if the signs are different, so what do I mean by if the signs are different? A negative and a positive, or a positive and a negative. It doesn't matter which order, right? It just matters that they're not the same sign. If that's the case, and you're multiplying and dividing, remember it's the operation that tells you which rule to use, then the answer is always negative. And that's it. Pretty much. We're going to look at a few examples first because I want to show you some things with parentheses and all. I want you to look at the format and be able to see these things as we go. But that's it. That is as far as the rules go. Now, two rules. Now, here's the problem with that. There are only how many of them? And they're dead easy, aren't they? How much work are you going to put into it if they're easy and there aren't very many?
Not much.
Not much. We don't study stuff we think is easy. Now, then what happens later? Forget it. So you've got to be careful. These rules are easy, but that means you've got to really pay close attention to the rules. Okay? So let's go through and look at some of these. The main thing, the biggest thing about these is that you need to make sure you know what operation you're dealing with so you'll know what rules to use. Okay? And we've talked about the ways of writing multiplication. So, say we have negative 6 in parentheses and a 3 in parentheses. What is it? What operation is indicated when those parentheses are side by side like that? Multiplication. Well, now I'm multiplying with terms. These just happen to be number terms, right? But they're still terms. So we need to remember the first part of every term is its sign. So you'll always determine the sign first. Do the first thing first. That's one thing that's not emphasized in the traditional way of writing those rules. The traditional way of writing those rules is that if the signs are the same, multiply and keep this, and the answer is positive or something. They put the operation before the sign, but the sign is actually the first step, right? So when should you do the sign? First. If you determine the sign first, then you're going to remember to do it first of all, and you'll already have it there waiting for you, and then you can go back and worry about the numbers. So the sign of the 6 is what sign? Now the 3 doesn't have a sign, so what do you suppose that means? That it's a positive, exactly. You don't have to always write the sign if it's positive, but you always have to write the sign if it's negative, right? So we have a negative times a positive, so are the signs the same or different? If the signs are different when you're multiplying, the answer is always a negative. And of course 6 times 3 just is 18. The multiplication doesn't change. Your job is simply to first, before you do the multiplication, find the what? Sign. Now, there's one number that has no sign. It's neither negative or positive, and it's a special case. And that number is 0. Because if you multiply with 0, what do you get?
0.
And 0 is neither negative or positive. Okay? So it's just 0. All right. Negative 2.9 times 2.8. What operation is indicated by the parentheses being side by side? And we're multiplying terms because we're in the algebra section now. This over there, we have to think of them as terms. So the first thing I need to determine is the what? Sign. So a negative times a positive is a negative. And then what do I do with the numbers? Just multiply them. 2.9 times 2.8. What's that going to give me? Somebody calculator. 8.12? Okay. And there's your completed answer. Now if you do it by hand, you could take it off and do it by hand, but again, right now we're trying to concentrate more on the signs. This is the sign rule for multiplication is also the same sign rule for what? Division. So, What operation is indicated by the fraction bar? Divide. So we're going to first determine the sign. The top is negative, the bottom is positive. So a negative divided by a positive is a negative. And 9 divided by 3 is 3. Negative 10 over negative 5. What operation is indicated by the fraction bar? Division. Negative divided by negative is a positive. Yeah, 10 divided by 5 is 2. Now, I put the plus there because I want it in your notes so that it really emphasizes that it's a positive. But do you need the plus in front of it since it's a positive? No. But it's not wrong if you put it there while you're learning. Do whatever you need to do while you're learning. Now we need to talk a little bit more about 0. Remember that 0 is the only number that has no sign, right? And remember that when you're multiplying with 0, it doesn't matter what you're multiplying with, anything times 0 is always what? 0. But when you divide with 0, you don't always get 0. There are two different things that happen to you when you divide with 0. And it depends on where the 0 is. If you have 0 over any number, I'm just using n to stand for any number. If you have 0 over any number, that does indeed give you 0. Okay? But if you reverse it and put any number over 0, that one is not 0. Do you remember what happens when you try to divide by 0? Can't do it. Do you remember what it's called? Undefined.
Oh, yeah.
Okay?
There is no answer.
No answer. It's undefined. Okay? There's no such thing. You cannot divide by 0 because 0 stands for nothing, and we don't know how much nothing you can put into something, right? So division by 0 is what? Undefined.
Well,
You need.
how can you sign undefined?
It has no sign. It's just undefined. Just
So
undefined
if
period.
I have this on the computer or something.
Then there'll be a question. There'll be a thing you select that says it's undefined. Okay. All right. So 0 over 4. What would that equal? 0. 5 over 0. What would that equal?
Undefined.
Undefined. Right? You have to make sure you know the difference. Now be careful. These will definitely be on your test. And you've got to know which one's which. All right? So you've got to make sure you know which one's which. Okay. No notes to use on the test? No way.
When we have a first test.
We've got about 3 more classes to go before our first class test. Look at this one. Negative 13 over 6 divided by negative 16 over 11. What operation is indicated here?
Division.
But with what kind of numbers? These are, well, fractions, yeah. Look, these are fractions, right? Okay. Well, the fraction rules take over. But we can go ahead and determine the sign before we even begin. Because the sign rules are the sign rules no matter if they're fractions or not, aren't they? What's a negative divided by a negative going to make? And then we can go back and divide the numbers, but what do you know about dividing with fractions? So we're going to change it to multiply by the what? So that's going to become 11 over 16. Is there anything that will reduce 11 to or 13 or 16? Nope. So you're just going to multiply how? Straight across. Notice I didn't even bring down the minuses. Why? Yeah, I've already determined the sign of my answer, so I don't care. All I'm doing is working now to find the number. So 13 times 11 is... Sorry?
143.
143, thank you. And 6 times 16 is...
I got a question.
And there's your compiled answer. Yes, sir.
Why is the 16 over 11 in parentheses?
All right. The reason they're doing that to you right now is because they want to really emphasize the negatives. They're going to do that a lot. Because, oops, they think that this will confuse you right now. Okay? So that's why they're putting it in parentheses. Now, but later, they wouldn't do this. But of course, most of the time, they wouldn't put that division symbol in. If they wanted you to do this, they would normally write it like that, right? The big fraction bar means divide that fraction by that fraction, okay? So normally, they wouldn't use the division symbol. But because they did, they also wanted to put the parentheses in there so that it wouldn't confuse you to have the division and the minus one right after the other.
I think that's wrong, right? To do like this, or it's good.
It's all right, but it just doesn't look as good. This is the way it would normally be written. Do you have a question?
This may be really stupid, but I'm confused on it.
It's all right.
Is it negative 13 over positive 6?
The negative is really in front,
Okay,
but it doesn't matter.
can that, okay, that doesn't ever matter.
No, because a negative divided by a positive would make the whole fraction negative.
Okay.
There you go. Good question. I didn't write it very neatly. Okay. Now, let's look at one that has both operations put together. Say we have negative 10 with parentheses negative 6 over 7 minus parentheses negative 8. And this brings us to something we've got to be really careful about, and that's what happens when you have a negative in front of a parentheses. We've had numbers in front of a parentheses. So what does it mean if you had 4 in front of a 6? And a positive times a positive is positive. 4 times 6 is 24. Well, the same thing happens when you have a negative in front of there. Now, you may have seen this before, because I know most of you had some algebra. You know that if there's no number in front of the parentheses, there's a 1. But even beyond that, all you need to remember is that this is the whole parentheses. It has a coefficient. The coefficient for this parentheses is the sign. Now in arithmetic, we just brought those pluses and minuses down. But now those pluses and minuses are the sign. So this parentheses has a sign in front of it. And it's still a coefficient, which is just a fancy word for multiplication, multiplier. So it means to take this negative times the sign inside. So what is a negative times another negative going to make? And nothing times 8 is just going to stay what? 8. So your multiplier doesn't have to be a number. It can be just a sign. So let's go through a few of those and then we'll come back to that problem. Say I have negative in front of a 2. That negative is the coefficient or the multiplier. So what's the sign of the 2? Well, the sign of the 2 is positive, and then we have a times a negative. So a negative times a positive is going to make a, and nothing times 2 is just going to stay 2.
Well,
1 times
yeah,
All right.
nothing,
Well,
because that would be 0, right?
no, nothing is. I mean, there is no multiplier. So I'm not saying 0, because if I wanted to say 0, I'll say 0. But there really isn't anything there. Now there is a 1, and you can say 1 times 2 is 2 if you want to. But okay, and that's fine if that's what you want to do. But nothing times something is, if there's no number to multiply. Okay, how about if I say no number instead of nothing? Will that make you feel better? Okay, no number times a number just stays the number itself, right? Or you could put the 1 if you want to. I think that putting the 1 there is going to lead to issues later. So if you can try to get away from it, then you'll be better off. Now, what if I have a plus in front of there? Positive times a positive is still a positive, and no number times 3 just stays 3, right?
I have a question, but you explained it to us, but it's not out of the rule, right? It's like the rule that we have. Like, if the signs are different.
Yes, it's the same. It's the same exact rules. You're just using the sine rules.
Okay.
Yeah. But sometimes when you're multiplying, there's no number to multiply by with, but you still have to use this. Still have to multiply with the sign, okay? Because now we have rules for the signs as well as rules for numbers. So you still have to obey the sign rules. So let's do this one again. Start by simplifying the top. A negative times a negative is a positive. 10 times 6 is 60. We'll go to the bottom. Now we got to do the parentheses first, right? So I'm just going to bring down the 7. There is no number to multiply by, but there's a sign. So what's a negative times a negative going to make? Positive. Positive what? 8. And then we'll just add 7 and 8, which makes what? 15. And then, what does this mean over here?
60 divided by 15.
60 divided by 15, which is 4. Okay. So, here we just had multiplication. So negative times a negative made a positive. 10 times 6 is 60. In the bottom, we had a parentheses. So we brought the 7 down because the 7 wasn't part of the parentheses because it was separated by a sign, right? Every time you see a sign, you know that's a different term. So we brought the 7 down. That negative was the multiplier for that parentheses, right? So a negative times another negative makes a positive. And no number times 8 just stays what? 8. And then now that the parentheses is gone, we just have to add those two things together. And 7 and 8 made our 15. And what does this fraction bar mean to do? And 60 divided by 15 is 4. Positive 4. There you go. Okay? She's in such a hurry to get out of here. This is your last class for the day. The weekend starts, doesn't it? Okay. All right. So what we're going to do is go up and look at some things with the sign rules. Concentrate on the signs. From now on,